Hello everyone, myself Dr. Venkat S. Mani, Head of Chemical Engineering Department, KKY Institute of Engineering Education and Research, Nasik, Maharashtra. We are going to discuss on electrophoresis technique. This is one of the advanced separation technique for the separation of the different components. Okay, this is under the subject of advanced separation processes. Okay, electrophoresis is nothing but under the influence of electric field, positively charged particles are transferred to the negatively charged electrode and the negatively charged particles are transferred to the positively charged electrode. That means positive is moving to the negative and negative particles are moving to the positive direction. That means there is attraction between the opposite pole and repulsion between the two positive sides or repulsion between two negative sides. That's why the opposite poles, positive and negative, have always the attraction. Okay. Now the electrophoresis technique, this use of the electric field for the positive negative electrodes and the positive charge and the negative charge particle take the benefit to separate the components accordingly. Okay, the components are separated in zone or bands in buffer and stabilized in solid, porous or any other support medium. For example, filter paper, agar gel or polyacrylamide gel. Okay, electrophoresis separates biomolecules like proteins, nucleic acids and amino acids. These are the applications of electrophoresis. This is the best example as a technique for the application for the removal of proteins, nucleic acid and the amino acids. This electrophoresis technique you can understand easily by using this schematic diagram. See here. This is nothing but the plastic gel box. Okay. Now this is the sample loading. This is the gel over here. See, this is the cathode, negatively charged. This is the anode, positively charged. The particles are migrated to the anode is nothing but the anaphoresis, and the particles are migrated to the cathode side is called as the cataphoresis. That means positively charged particles are migrated to the negatively charged electrode and negatively charged particles are migrated to the positively charged electrode, anaphoresis and the cataphoresis. Okay, then what are the different factors? What are the different factors which going to hamper on the performance of electrophoresis technique? See this one. The main factor is strength of the electric field, which impact on the performance of the separation, degree of separation, strength of the electric field. The second is charge of the sample used, it's very important. Then size of the molecules also, because you will have the positive, negative particles as well as the cathode and the anode as a electrode. So size matters. Okay. Next is the hydrophobicity of the sample taken. It hampers depending upon the hydrophobicity of the sample. You will have the different results for the degree of separation. Okay. Next is the ionic strength of the buffer. Ionic strength also matters for the degree of separation. So these are the different factors which are going to hamper on the performance of the electrophoresis for the separation technique. So we have discussed about what is meant by the electrophoresis, and this is the one of the technique in the advanced separation processes. Then different examples where the electrophoresis technique is used. We have seen schematically the diagram of the electrophoresis, how the positively charged particles are going to attract to the cathode, which is negatively charged, and the negatively charged particles are going to be attracted to the positively charged electrode as a anode. That is, the first one is anaphoresis, second one is a cataphoresis, and we have seen the various factors which going to affect on the performance of the electrophoresis process or for getting the degree of separation of the different components. With this I stop. Thank you very much.